Okay. Today we're looking at Chapter 10, Alkanes and Alkenes and their respective reactions. This is out of Chapter 10.1 and 10.2 out of the Heinemann Chemistry 2 Enhanced textbook. And I'm Mr. Jaraba, and it's 2014. So today, the learning intention is that you guys as students will be able to describe the different types of reactions that alkanes and alkenes can undergo. And by the end of this class, not only will you be able to describe them, you'll be able to illustrate them by writing down equations for those reactions. And you'll be able to distinguish between a substitution and an addition reaction. For these online classes, here's what I would recommend. Number one, have your textbook open and not Game of Thrones while you work. Feel free to pause the video at any time and go backwards and make sure you understand what's going on. Please write down the learning intention and success criteria. And by the end of the class, you should be able to be confident that you can successfully fulfill the criteria. So by the end of this class, if you can't do this, if you can't write equations illustrating the reactions and distinguish between substitution and addition reactions, then you might need to go back, listen and research and get it right. These are important things. Leading on to that is number 3. Please make notes, but please do not write everything from each slide word for word. Make up summary notes. Use the textbook, use these slides, use whatever it takes to make sure you understand what's going on and you can use for revision as we get towards exams. And finally, and most importantly, is number 4. Please make sure you post your questions onto Edmodo. Make sure that the chemistry community can help you out, and make sure I can help you out, and make sure you use that space for you. If you have any questions at all, put them on Edmodo, and if you know the answers to the questions that people are asking on Edmodo, feel free to chirp in, reply to them, help each other out. It'll make life easier. Okay, let's get started. Alkane and alkene reactions. So let's have a look at 10.1, alkane reactions. I want to jog your memory first. Try and figure this out. Alkanes are what? Saturated or unsaturated hydrocarbons. And what does that mean? If it's saturated or unsaturated, what does it mean? Take a couple of moments and answer that question. Okay. Not only do we know that alkanes are saturated, and are saturated because they have no double bonds, that all the reaction points have been taken. They're also nonpolar because the carbon and hydrogen have a very similar electronegativity, and they're also symmetrical, so there's nothing there to cause a difference in electronegativity and then make something polar like a magnet. Alkanes are also insoluble in water because they're nonpolar. Like dissolves like, water is polar, it'll dissolve polar things. Because it's nonpolar, it won't dissolve in water, but you can dissolve it in things like oils, which most of them are nonpolar. And because alkanes are usually very small, they don't have any specific groups that cause really strong bonding, like hydrogen bonding or disulfide bonding. They're only attracted by dispersion forces, and they therefore only have low melting and boiling points. So because there's a lack of double bonds, alkanes are really stable. And they're very resistant to reactions other than these two, combustion and substitution. And here's a picture of ethane and a space model of a larger alkane, meth, eth, pro, bute, pent, hex, hept, octanol, octane, there we go, there's octane, stuff you put in petrol. Combustion and substitution reactions are what we're looking for today. So there are 2 types of reactions for alkanes. The first one is a combustion reaction, which means boom. Alkanes can be oxidized in a combustion reaction, just like this burning piece of wax here. It's not really alkane, but it's something burning. And in combustion reactions, as you expect, there's a lot of heat energy being released, and that's why we use it for fire and combustion engines. And here's 2 examples out of page 145, I believe, of the text. Methane and oxygen gives you react together in a combustion reaction to give you carbon dioxide, water, and energy. And this one here, octane, which was on the previous page, over here, 10.1, picture of 10.1, octane also reacts with 25 moles of oxygen and reacts to give you 16 moles of carbon dioxide, 18 moles of water, and a whole bunch of energy. The stuff that makes your car get warm and get you to burn your hands if you burn octane on your hands, which would be crazy to do, so don't do it. Okay, here's what I want you to do. I've said that alkanes can be oxidized in a combustion reaction. I want you to prove it. For these two equations here, prove that carbon is actually being oxidized. Remember redox reactions, remember oil route. Pause the video if you need to, and then when you're done, move on. So alkanes can undergo combustion reactions and they can also undergo substitution reactions. Combustion reactions, which we looked at before, and now substitution. And substitution is best, if you don't know what we're talking about when we use the word substitution, think of a basketball game, a netball game, or a soccer game. And when you make a sub in those games, you take out one player and you swap in another. For alkanes, we swap out a hydrogen and we swap it for another atom or a whole functional group. We swap out one for another. So on page 145, there's a bit about substitution reactions, and I want you to figure out how it works. How does a sub actually work? How do you swap out a hydrogen and put another atom on there? So have a look at page 145, read under substitution reactions, and can you please draw diagrams of how ethane and chlorine gas form different types of substitution reactions. There's 4 variations here on the page, but I want you to draw it and figure out how it actually works. Does anything get lost? What do you end up with when something leaves? What are the other byproducts? Okay, so alkenes, and we're going to be looking at ethene as ours. Alkenes are different to alkanes because they have that double bond. That makes them unsaturated, and that makes them a little bit more different and a little bit more reactive. They are unsaturated. They are still nonpolar because they're symmetrical and the electronegativity of carbon and hydrogen is relatively the same or very close, so there's no polar regions, delta plus, delta minus, that is significant. Again, they're insoluble in water, so you won't be able to dissolve ethene in water, but in some non-polar substances you can. This is flammable as well. And there are 2 reactions that we're going to look at for alkenes. This is an addition reaction, not a substitution, an addition reaction, or a polymerization. Addition or polymerization. So let's have a look. Addition reactions are the first type, and when the double bond here is attacked, it allows an atom or a functional group to be added to that whole molecule. Not swapped, but added. And here's an example down here. Ethene, when reacted with bromine gas, the bromine doesn't swap with the hydrogen, it actually adds. It breaks the double bond and adds. So the bromine attacks the double bond, and then it attaches itself there and there. So the other bromine attacks the double bond. When the double bond breaks, because it's a covalent bond, there's 1, 2, 3, 4 electrons there. So bromine takes 2. It takes one for itself. Bromine takes another one for itself, and then one's left there for the bond, and you end up with 1, 2 dibromoethane. 1, 2 for the locations on the first and second carbon. There is 1 bromine for each dibromo, and then ethane, because it is an ethane, meth F, ethane. And this ethene-bromine reaction can work with any alkenes. Have a look on the right-hand side here on figure 10.3. When you add bromine, which is this red stuff here, to a saturated liquid, a clear saturated liquid, the red acts like a food dye and it just spreads its way through that unsaturated liquid. And that's why it's tinged yellow. The bromine hasn't reacted with anything, and so the red dissolves and spreads out, causing that clear, maybe it could be pure water, to turn into that color. However, when you have a unsaturated hydrocarbon, one with double bonds, the bromine acts on those double bonds, and what was red over here becomes clear. So when you drop this red stuff into this bottle here, the red just disappears. You can't see any more red because the bromine complex, which gives you red by itself, has been dissolved and added to the saturated hydrocarbons. So addition. Addition can also happen not just with bromine, but it can also happen with water. And this is where we get our good friend ethanol. When we react water with with any double bonded hydrocarbon, particularly ethene, you need a catalyst. H3PO4 is phosphoric acid. Phosphoric acid is the catalyst, and at a certain temperature, 300 degrees, which is really warm, the water breaks into its constituent parts and adds to ethene. It gets cut over here. You have a H by itself that goes to one, and you have OH, it's terrible mouse work, goes to the other. And you can see the H is added there, or could be one of any of those three, and an OH is added there. And there's no byproducts. So when ethene is added with water, providing there's a catalyst, you have ethanol. And if it's chlorine gas or bromine gas, you'd end up with chloroethane or bromoethane, like we saw on the previous slide. What I'd like you to do now is this. Explain the difference between addition and substitution reactions. For alkanes and alkenes, they undergo either addition or substitution. What is the main difference? Write it down and then move on. Okay. So alkenes can undergo an addition reaction, and they can undergo an addition polymerization reaction. Okay? So it's an addition reaction, but it's of a different type. And that's when you add alkenes together. So you don't add an alkene with another small or big thing and it sort of adds to it, but you add the same one together multiple times. And this polymerization comes from the Greek. Poly, many. A polygon has many sides. Mono means singular in the Greek. And mono, like monopoly, or to do a mono on your bike, means one. And the suffix mer means parts. So you put them together, polymer is many units, monomer is 1 unit. So you get multiple monomers and you add them to make a polymer. Ethene, our good friend ethene over here, we have n amounts of those, n could be any number, and in the presence of a catalyst, we can add them to make a chain. And we cut, using the catalyst, it cuts the double bond, causes the single bond electrons to go out this way, and then the next one joins onto it as well. And then so you have this. This is an ethane monomer joins to another ethane monomer. And it just keeps on going and going and going on both sides. And you end up with ethene to polyethene. Now it's good to note that it's still polyethene, it's not polyethane, even though it doesn't have the double bonds anymore. There's no double bonds there. So why is it polyethane? Why is it polyethene? Go have a look and find out. I'm not going to tell you. Remember that for polymerization, you always need a catalyst to help break the double bonds. With some of these previous reactions, when you have like bromine has enough electronegative power to break that double bond by itself. But when you have these ethenes by themselves, when they're stable by themselves, they don't like to break themselves apart. So you have to have a catalyst that can lower the activation energy for this breaking of this double bond, and you also need some temperature. Like I said before, the N tells you the number of monomers. Okay, and that could be 10 if you wanted. You'd make a very small chain, but you could have 10. It could be 10,000. And then you start making strands of plastic, because plastic is a form of polymer. And the length of the chain could be endless. As long as you have enough ends, you could have enough length. Now, when you have a polymer, it presumes that you have the same monomer making the same thing. So when you look at your jumper the next time, or a piece of clothing, and you see that it's made out of a poly something, go figure out what it's made out of. And if it's made of more than one monomer, it's actually called a copolymer, because co means like a company, multiple. So there's multiple polymers that make up the parts, a copolymer. On page 148, there's some examples there, like ABS or polystyrene. So now we're getting to the end. Alkanes and alkenes have certain reactions. Alkanes in particular can undergo combustion or substitution reactions. These combustion reactions, you should know how they work, and you should know that combustion reactions are really just a massive, explosive, hot oxidation reaction of carbon. And when alkanes undergo addition, it is not the same as substitution. So when alkanes undergo substitution, it's not the same as addition. And we use that football reference, but maybe a bit more comical is looking at these football players. They're doing a substitution, they're swapping, versus weight gain, like Ben Stiller here in dodgeball. He's just putting on the weight. He's not giving anything back, he's just putting it all on, based upon all the stuff he's eating. Now we're looking at alkenes. The summary is this. Alkenes can undergo addition and additional polymerization reactions. And the double bonded carbon here is converted into a single carbon bond here. And when the bond breaks, that's where those pieces add. It can be a functional group, or it can be just another single atom. When you have alkenes in water, it breaks up into a hydroxyl group and it gives you an alkanol. An alkene in chlorine or bromine gives you chloroalkanes or bromoalkanes. Now when you have multiple alkene monomers and you join them together under the presence of a catalyst, you can form polymers. Now it's up to you. Based upon what you've learned and what you've been exposed to, please do the following. Do the relevant questions from Chapter 10, based upon your Area of 2 student guide. Write down summary notes for 10.1, 10.2. It shouldn't take you long. And if you have any questions or comments, things that you don't understand or things that have been a light bulb moment, let us know. Put it in Edmodo, and if when you're on Edmodo you see someone else write something up, reply to it. Say, yeah, I totally agree. Or help them with their question. Or say, no, you're crazy. Work hard, and I'll see you next class.